Hi everybody. I had a couple people ask for some examples of factoring, so I wanted to show you how to do it. Here's one, 10x cubed minus 8x squared plus 15x minus 12, bit of a mouthful. With any factoring problem, the first thing you want to do is look for common factors. So look for some factor in each term that is common to all of the terms. Looking at this first factor, this first term, it looks like the factors are 2, 5, and x. And some of the other factors have some of the other terms have factors of 2, some of the other terms have factors of x, and some of them have factors of 5, but there's no other term that has all of those factors. So there is no common factor, so we can't factor out a common factor here. So we'll have to try something else. Since there are 4 terms, there's a trick. There's a trick we can use. This trick doesn't always work, but sometimes it works. The trick is we can try grouping these first 2 terms and these last 2 terms. To group like this, usually you'll want to have the terms in order of degree, so highest degree first and then down. The reason we can just add these parentheses is because addition is associative. It doesn't really matter if the parentheses are there or not. Now that we have these in groups, we can think about common factors just in each group. So in the first group, these 2 terms have a factor of 2 in common. Also, they have a factor of x squared in common. So let's factor out the 2x squared that they have in common. Okay, now this first part, after you factor out 2x squared, what's left over? Looks like it's 5x that's left over. And then for this second part, after you factor out 2x squared, what's left over? Looks like it's minus 4. Okay, quick check. If you distribute this back through again, you get 10x cubed minus 8x squared, so we haven't made any mistakes so far. Okay, now let's try factoring out a common factor in this second group. Okay, so 15x and minus 12. Let's see, 15 has a factor of 3 and so does 12. That looks like the only factor they have in common, so let's factor out that 3. From this first part, factoring out a 3 leaves behind 5x. And then from this second part, factoring out a 3 leaves behind negative 4. Okay. At this point, we aren't done because we actually haven't factored anything yet. It's still a sum here. To factor, we want to have a product. But if you look on this sum, each piece of this sum has a common factor. This time the factor is this whole chunk in parentheses, this 5x minus 4. So we can factor out the common factor, factor out the 5x minus 4. It's going to end up over here, 5x minus 4. Or you could write it on the left, it doesn't matter which side. And now we have to figure out what's left over. So from this first part, 2x squared times 5x minus 4, when you factor out 5x minus 4, it's 2x squared that's left over, like this. And then from the second part, when you factor out 5x minus 4, the stuff that's left over is this 3. So plus 3. Okay, now this is factored because the whole thing is a product. This multiplication in the middle is the last operation that would happen according to the order of operations. So this is factored. Okay. We can double check that this is correct by multiplying this back out and seeing if we get back to where we started. So distributing everything here, let's see, we can do this one times this one, 2x squared times 5x, that's 10x cubed. Looking good so far. Then we can do 2x squared times negative 4. That's negative 8x squared. Looking good. Okay, now we can do 3 times 5x. That's plus 15x. And then finally 3 times negative 4, that's negative 12. And as you can see, this is the same thing as what we started with, so we know that we did this factoring correctly. All right, let's try another one. How about this? 12x to the fourth minus 4x cubed plus 30x squared minus 10x. So again, we'll start out by looking for a common factor. All of these coefficients are even, so we know there's a common factor of 2. Also, every term has an x in it, so we can start out by factoring out 2x from everything. So what does this leave behind? From this first part, 12, let's see, factoring out a 2x, that's going to leave behind a 6. And factoring out an x, that's going to leave behind an x cubed. So 6x cubed from that first part. Now from the second part, factoring out 2x is going to leave behind negative 2x squared. Now from the third part, factoring out 2x is going to leave behind 15x. And then finally, this last part, factoring out 2x is going to leave behind negative 5. Okay. Now, this is a product. We do have 2x times something. But whenever you're factoring, you want to factor as much as possible. This stuff in parentheses, it's possible that we could factor this part even more. This 2x on the left, we're going to leave it alone. But the stuff in parentheses, what could we do to factor this? Well, there aren't any common factors, but we could try our grouping trick. We could throw some parentheses in here like this, and then see if we can factor. So this 2x is going to stay put. Okay, now in this first group, there's a common factor of 2 and also x squared, so we can factor out 2x squared, and that leaves behind 3x from this part. And then from the second part, this leaves behind minus 1, it looks like. Okay, plus. Now we can look for a common factor in this second set of red parentheses. It looks like the common factor there is 5. And then figure out what's left over after you factor out 5. From this first part, we have 3x left over. And then from the second part, minus 1. Okay, now we have to see if there's a common factor that we can factor out from these two terms. And sure enough, there is a common factor. The common factor is 3x minus 1. So let's factor out the 3x minus 1. So the 2x is going to stay put. The 3x minus 1 we're factoring out like this. And now, what's left over? From this first part, 2x squared is left over. And from this second part over here, 5 is left over. So plus 5. Like that. Okay, now we have a big multiplication. It looks like we have a set of extra parentheses here that we don't need, so maybe we should rewrite it to get rid of those. 2x times 2x squared plus 5 times 3x minus 1. And again, if we wanted to check this, we could multiply everything out and see if we get back to where we started. But let's not check this one. I think maybe we did it right. Well, let me know if there are any other problems you want to have a look at. Bye.